So what you're doing with a differential equation is you are given the derivative, that's dy dx. You're going to do an antiderivative. You're basically going backwards a step trying to get the original equation. Here I told you that if you plug in 0, you should get 5. That's what's called an initial condition, like the starting place. It's not always 0 though, so just be careful. It could be y of whatever, but it's still called an initial condition because whatever the numbers are, it's like your starting spot. All right, so real quick, what is your antiderivative for this? Like if that's dy dx, we want to go backwards a step and get y, what would that be? So good, 2x squared plus 3x, and then plus what to make sure that this is true? And so at the end, we would put plus 5. Good. Because if you plug in 0, you want to get 5. And that's the answer. And essentially, that's what this topic is. Obviously, the problems are going to get more complicated, but that's what it is. Okay. So here are your steps. If you're a steps person, I've got you. All right. Step 1, you're going to separate the variables. Y will always go to the left. X will always go to the right. So actually, let me put that here. Y will always go to the left. X will always go to the right. So separate the variables. And then this is your step that's calculus. You're going to do the antiderivative. That's like the one step that's calculus. Do the antiderivative. I make this next part its own step because it's so important. You have to put a plus C. Technically, that should be part of this step. Like when you take an antiderivative, you put plus C, but it's so important that I make it its own step. Put a plus C. If there is an initial condition, this is where you would use it. If there's not, just skip that step. So if you're given an initial condition, that's where you would plug it in. If not, then just don't. And then your last step is solve for y. Your answer, like your final answer should be y equals whatever. Now I have a little bit more space here, so I want to clarify one thing. There's 2 different ways these can turn out, whether you have an initial condition or not. If you do not have an initial condition, that is what's called the general solution. And this, what I'm bringing up right now, is going to be really important next class. We're going to do slope fields. Does that ring a bell at all? Slope fields, they look like those magnetic field things that you do in, you do those in chemistry? Yeah, like they have the little line segments. Anyway. Oh, cool. Yeah, it's not a magnetic field. I just bring that up because that's kind of what it looks like. So this is going to relate heavily to what we do next class with the slope field. The general solution is an infinite number of answers. I can't talk and write at the same time. You have infinite answers. And so you leave the C in there. And the reason that's infinite answers is because C could be anything. So you would leave the plus C in there. Okay, infinite answers. If you have an initial condition that you plug in, that is called a particular solution. Again, I can't spell and talk at the same time. A particular solution, which is only one answer. And so you won't have C in there. You'll have solved for C and figured out what it actually is, and you're just getting one particular answer. So that's the difference between general solution and one particular solution. Basically, we're just going to practice a whole bunch of these guys, and I'm excited. So looking at this one, you want to get all the y's to the left and all the x's to the right. So I'm going to multiply the 3y squared over, and I'm going to multiply the dx over. The other way you could think of that for this is cross multiplying. You're going to have 3y squared dy equals 1 dx. And the colors don't show up very well up here, but I'm going to try anyway. I always make this a different color so that you can see the step happening. Your next step is to do the antiderivative. So yeah, it doesn't really look any different, but if you want to use a different colored pen or something. Anyway, now we're going to do the antiderivative. So what is your antiderivative for 3y squared? y cubed, perfect. This is the calculus here, equals antiderivative of just 1, just x, and then you have to put plus c. It is so important that I write it as its own step. Now, if there's an initial condition, here's where you would use it. This one doesn't have one. Great, less work, so skip that. And all we have to do is solve for y. So what would you do to get y by itself? Cube root. And so it's y equals cube root x plus c. So did we get a general solution or a particular solution? General, and it's an infinite number of answers, which is cool. It's an infinite number of answers. That's neat. Let's try it again. You want to move y to the left and x to the right. So this is, again, another situation where you could just cross multiply. You're going to multiply over the 4y and then multiply over the dx. And then antiderivative. This is your one step of calculus here. Antiderivative for 4y. 2y squared, perfect, equals, over here, I usually cover up the coefficient. It would be 1/6 x to the 6th, but there's a 3 there. So it'd actually be 3/6, which would be 1/2. So 1/2 x to the 6th plus, now there's a 1 there, so x plus c. Now this one has an initial condition. So we're going to plug in 0 for x and -2 for y and see what we get. Okay. So if you plug in 0 for all of these x's, this would all just be 0. You would just end up with c on that side. If you plug in -2 over here, what are you going to end up with? 8. Good. And then here's what you do. Once you figure out what c is, you recopy this step exactly like it looks, except instead of a plus c, we're going to write plus 8. You just put whatever number that was in there. But you just go back a step, recopy it, except put the number that you found in there. And now we're going to solve for y. So what would you do to get y by itself? So y by 2. Here's my advice for this. You want to do as little work as possible, because the more simplifying you try to do, the more room for error there is. Okay, so basically do nothing. If you want to divide by 2, here's how I want you to do it. You put all of this over 2 and cross that out. I'm not telling you to be lazy. I'm telling you to be efficient. Do as little work as possible. And then what's the last step? Now, here's the conversation around square root. When you square root, you normally put plus and minus. And if it was an infinite number of solutions, like the general solution, you would just put plus and minus square root, be done with it. But if you only want one answer, you have to choose plus or minus. And it comes from the initial condition. Do you see how it's negative? That means we want the negative square root. So the initial condition tells you. So we want negative square root of this entire disaster. And literally just copy it over. Don't do a copy error like I just almost did. Just copy it literally exactly like it looks. Do as little work as possible, because the more meddling you do, the more likely it is that you'll have a mistake. So just do as little as possible. And just don't do a copy error. All right, these ones aren't going to be cross multiply. We want to move this y to the 4th over to the other side. That means you're going to divide it. Don't write this, though. That is technically what we're doing. You're dividing the y to the 4th over, but how else could we write that would maybe be a little bit better? -4, good. So y to the -4th dy, and then you're going to multiply over the dx. So what's left over there is 4x dx. I usually get asked at this point, and I'm sure at least one of you is thinking this, why didn't you divide over the 4 as well? I've been doing this a really long time. You can, and that's kind of personal preference. If it's not a variable, it's just a number, it's sort of up to you. But here's the thing. You want your answer at the end to be y equals. So whatever you move over, you're just going to have to move back. So the more you move over, you're creating more work for yourself. Does that make sense? So like move over as little as possible is my suggestion, but it is technically up to you. All right, antiderivative. Now it's tricky because it's negative, so we're going to be really careful. You need to add 1 to the power. So that would make it good. And then out front, a negative 1/3. We'll fix that in the next step. Over here, 2x squared plus c. And we are going to plug in the initial condition now, but I would rewrite this. You can erase it and fix it if you want. I'm just going to write a whole nother step. That y cubed has to go down to the denominator, so it'll look like this. And I would just take a second and do that, because when you go to plug in a number, it's a whole lot easier if you don't have a negative exponent, is my opinion. I think most people kind of agree with that. So we're going to plug in 0 for x and negative 1 for y. So again, if you plug in 0 for x, that's kind of nice because all that goes away. You just get c on that side. If you plug in negative 1 for y, negative 1 cubed, negative 1. So the negatives are actually going to cancel, and you would just get 1/3 for c. So we're going to recopy the previous step. Just recopy it literally exactly like it looks, but put a 1/3 in there for c. And I ran out of space, so I'm going to have to come up with it. Last step is to get y by itself. Watch me point to this, because again, I'm going to try and save you from writing. Like, the less writing you do, the better. You would take this y cubed and multiply it over here. Are you following me? And then you would take all of this and divide it over there. So essentially, the y cubed and all of this are just going to switch places, because you would multiply this over and then you would divide all of this over. Okay, so they're just going to switch places. So you're going to have negative 1 over 3 times all of that equals y cubed. So these two items essentially just switch places. And then what's your last step to get y alone? Cube root. And you don't have to worry about plus and minus when it's an odd power. That's only for the even powers. So like when you're square rooting. So cube root of this gigantic mess, and that's your answer. If it looks like a disaster, you probably did it right. And I'm sorry, I encroached on the space for number 5. It'll be okay. So what do you notice about number 5? Look through there, because you should be like, hey, wait a second, something's missing. There's no y. It's actually good, because it'll be less work. To separate the variables, all you need to do is multiply over the dx. So we're going to have dy equals all of that dx. If you want, you can put a 1 in front of the dy. Sometimes that helps people. So if you want to just throw a 1 in there, you can. And then antiderivative. So what's your antiderivative of just 1 dy? And that's why that's awesome, is because your goal at the end is to get it to be y equals, and check it out, it already is. Great. Fingers crossed on this one. How do we do this antiderivative? Since I can't just write the answer. Good. Okay, what are we going to let you equal? Good. Du would then be 3x squared dx. Sorry, I kind of squished it in there. Now, you want to compare with the problem. We have an x squared dx, but I need to turn the 3 into a 5. 5/3, good. Nice job with fractions. 5/3 du equals, I ran out of room. 5x squared dx. I didn't have room for the dx, I'm sorry. So when you go to substitute in, 5/3 goes out front, du goes at the end. What's still there? Awesome. What's your antiderivative of 1 over u? ln of u. So this is going to be 5/3 ln of u, which is x cubed plus 4. And then to top it off at the end. Good. Was there an initial condition? Gosh, I hope not. No. Okay, then that's just our answer. Let's do one more and then I'll give you a break. Because this one's not too bad. Do you see how there's also not a y in this one? Yay! Just multiply over the dx and you'll have them separated. And again, if you want to put a 1 in front of the dy, sometimes that helps. So antiderivative, and it'll be y equals, which is fantastic because that's your goal. This is technically also a u substitution, but this is a real basic one. What would you adjust for the 5? So just put a 1/5 out front, and then you don't have to do all that other work. It'll be 1/5 what? Sine 5x plus c. There was not an initial condition, so that's just your answer. So sometimes they will unfortunately write the problem like this. Do you see how it's a y prime? That means the same thing as dy dx, but you have to rewrite it as dy dx because you can't separate the y from the x when it's written like y prime. Okay, so first of all, I'm going to rewrite that as dy dx. I'm just going to kind of put it up here. And then I'm also going to divide over this square root so the dy dx is alone. So I rewrote the y prime as dy dx, and I'm going to divide this to the other side. So it'll be x over that whole square root. Again, algebra is just moving stuff. Like I'm just going to move that over here. And then once again, what do you notice is missing? Which is good, because then once we do an antiderivative, it'll just be y equals, which is what we want in the end anyway. So multiply over the dx. So it's just going to be all of this dx. If you want to put a 1 in front of the dy, I suggest that. I think it helps. And then antiderivative. So it will be y equals, and oh my gosh, how are we going to do this antiderivative, guys? Substitution. Cool. What would u equal?
3 plus x squared.
Sweet. See, I think once you guys realize it's u substitution, you're good. We just need like practice identifying it. Now, see, that one's technically a u substitution, but I don't. Oh, on the other side. See, here, that is technically a u substitution, but I don't write u equals 5x, du equals 5 dx, 150. Like, I just go, oh, I need a 1/5 out front. Boom, let's go. You know, like, save yourself time. All right, so this du would be 2x dx, and then you have to adjust with a 1/2. Perfect. So 1/2 goes out front, du goes at the end. We need to figure out what's still there. It would be a square root of u, but it's in the bottom. So it would be u to the negative 1/2. 1/2 because it's a square root, negative because it was in the denominator. All right, so now we're going to do the antiderivative. You add 1 to the power. So negative 1/2 plus 1. Positive 1/2. And so out front, you need a 2. Which is actually kind of nice because of that 1/2 that was there. These are going to cancel. And then what at the end to finish it off? Plus c. It's so important to make its own step. Now this one had an initial condition. Do you see that there? I kind of wrote all around it. Do you notice how it's not 0? Sometimes it's not 0. You have to be careful. We're going to plug in 1 for x and 14 for y and see what we get. All right, so 14 for y, 1 for x. 1 to any power is just 1. And so then what would we get for c? I feel like I made a mistake somewhere. Yeah, I forgot to plug u back in. I'm sorry. I was like, did your instinct ever kick in and you're like, hey, hold on, something does not feel right? I apologize. I was like, wait, this is not right. What was u? 3, I'm sorry. Square root 3 plus x squared plus c. I was like, something does not feel right here. think that that is wrong. Okay, now we'll plug in the initial condition. I'm sorry. You guys caught it this. So 14 equals, if we plug in 1, what'll that be? Square root of 4. So 2 plus C. So C is 12. And so we're going to go back and recopy that step, except plug in the 12 for C. And Y is already alone because it was just dy equals in the original problem. I'm going to beat myself up over making that mistake for a really long. Do you ever do that? Like, that's going to bother me that I did that. I'm so sorry. All right. For this one, how would we move the y over? Divide. So it'll be 1 over y dy. We have to divide it over, so it'll be in the denominator. And then multiply over the dx, so x squared dx. I feel like this is a good point to remind everybody. 1 over x antiderivative will go to what? ln. But these ones do not. 1 over x is the only one that works for. These you would have to write with the negative exponent, raise the power, then divide by. Do you know what I'm saying? Like, this is the only one that pattern works for. None of the, because I get people that'll do this and then write ln squared. Not a thing. Okay. I'm bringing it up because it happens. Okay. Antiderivative. This will be ln of y equals 1/3 x cubed plus c. Is there an initial condition? No, so skip that. We're going to get a general solution, infinite number of solutions. We have to get y by itself. Do you remember how to cancel out an ln? If we've all forgotten, this is pre-calc, so e. You're going to e both sides. Technically, you are, the word for it is you are exponentiating both sides, but everyone just says we're going to e both sides, okay? So those cancel. You get absolute value of y. Now I'm going to write out every single last stinking step for this first one so you can understand what happens. When we do the next ones, I'm going to kind of like gloss over it, but I want you to see what's happening. Whenever you add your exponents, because it's e to the power of this whole thing, that means that you're multiplying. So mathematically, it means this, e to the 1/3 x cubed times e to the c. Now, here's how we end up writing that. E is a value. Do you remember about what it is? 2.7. If you even know it's a number, I'm happy, but like 2.71, that's a number. C is a number. So we consider this whole thing one big number, and we write it in front as a coefficient. Oops, and I did a copy error there. Geez, what is wrong with me? There we go. So we put that out front just as one big constant. And then the last thing is to get rid of the absolute value. What that's going to do is put a plus and a minus in front. The reason why is, do you remember like what an absolute value technically is? Because everyone just goes, it turns everything positive, but that's because the definition is that it's a distance from 0. So a distance can't be negative. But the reason you get a plus and a minus, give me a number, a little number. 7. How can you be 7 units from 0? Exactly. That's where the plus minus comes from. Okay. Let's try that again. How would you move over the y? Divide. So 1 over y dy, multiply over the dx, 4x cubed dx. So I wrote every last step for that one. I'm going to kind of like breeze us through it on this one, but I want you to understand mathematically why it happened. All right, antiderivative. ln y equals what? X to the 4th plus c. Awesome. And then you would exponentiate both sides. C gets written out front as one big constant. And because of the absolute value, you put a plus minus. So your answer will look like this. Y equals plus minus c e to the x to the 4th. And if you want to write all the steps like I did over here, you can do that, but that's how it's going to turn out every time. We're just going to try one more. What's different about this one versus these two? Yeah, we're going to get one particular answer. There's an initial condition. Divide over the y, multiply over the dx. And then antiderivative. So that will be ln y equals what? 2/3 x cubed plus c. Here's where you plug in the initial condition. Don't try to rearrange anything. That's another common mistake. People will try to like move stuff around and then plug it in. Plug it in right away. We're going to plug in 0 for x, which is great because that all just goes. 3 for y. So that'll be ln of 3. You can drop the absolute value once it's a number because the absolute value of 3 is 3. If it's a variable, you kind of have to keep it in there. But if it's a number, then you can drop that. So recopy that step, except instead of c, put ln of 3. And then when you exponentiate both sides, e and ln are going to cancel for both of these. So when you take that and write it out front, it's just a 3. E and ln are going to cancel. So it'll be 3e to the power 2/3 x cubed. If you're like, hey, Miss Cole, what about the plus and minus? We put plus and minus on these because they were the general solution. It's an infinite number of answers. Here you want only one particular solution. And why did I want the positive and not the negative? This is positive right here. If this was a -3, we would have put a negative right there. Okay. And you're like, why is she hammering that so hard? Well, you'll see when you go to do the homework, because when they do the answer choices, 2 of them will be the same and one will have a positive and one will have a negative. So you got to think about that and make sure that you're paying attention.